Everybody, my name is Michael Olushola. I am an econometrician and I'll be talking about time series modeling and forecasting. And my last video we talked about the various tests used for time series modeling and forecasting, and we said we have unitary test, co-integration test, the long run and short run dynamics. We also have the ARDL modeling, and we went on to talk about the unitary test. We talked about why we test for unitary test, and I mentioned the three variates used for unitary test. We said we have the augmented Dickey-Fuller, which is an extension of the Dickey-Fuller test. It can also be described as the parametric unitary test. And we said we talked about the Lagrangian multiplier type of unitary test. We talked about the Gauge type of unitary test. And today we are supposed to be going into test equations for Dickey-Fuller test. Then that will lead us to the augmented Dickey-Fuller. So today we'll be talking about the Dickey-Fuller test, and I said we'll be talking about the test equations, the generalized test equations for Dickey-Fuller test. And I said the generalized test equation, the generalized test equation for Dickey-Fuller Dickey-Fuller can be expressed as follows. We'll be talking about different cases now. So let's assume for case one where we have both trend, we have intercept, we have our intercept and trend. We have our intercept and trend inclusive, and our generalized test equation will be YT equal to alpha plus beta trend plus rho YT minus 1 plus ET. This is our equation 1. Now this test equation is a generalized test equation for Dickey-Fuller and can also be said to be the all-encompassing, the all-encompassing test equation for Dickey-Fuller. Now we have different cases. We have for case 2 where we have no trend, where we have no intercept, where we have no intercept. Now for case 2 where we have our intercept, our test equation reduces to YT plus beta trend plus rho YT minus 1 plus ET. This is our equation 2. And we'll be talking about the third case. Our third case where we have no intercepts, and trend, no intercepts and no trend, and our test equation reduces to we have our YT equal to rho YT minus 1 plus ET. This is our equation 3. Now for the purpose of research, so for the convenience of the researcher, we can have the equivalent test equation, equivalent test equations as follows. Test equations as follows. For case 1 we have our change in YT equal to alpha plus beta trend plus gamma YT minus 1 plus ET. Now in my next class we'll be talking about we'll be stopping here for today. I kindly click on my bell button and kindly like the video, and stay tuned to my channel. We'll go into the equivalent test equations. I know questions will be like, how did we arrive at the equivalent test equations for this Dickey-Fuller? We'll be talking about that, and we'll be talking about the test hypothesis, that when do we have unitary tests, when does our test possess unit truth. When our rho is equal to 1, we say there is unit truth and it is not statistically significant. And you can actually forward your questions to my email. My email is Michael Olushola Tope